Go.
Being recorded. Okay. So today's lesson is goofy because before all of our proofs have been for like a specific triangle, like triangle XYZ, and today it's just going to be for like general cases. So
No.
Yeah.
it's really not that
I
bad.
got my pencil.
Oh. Okay. So let's just first talk about some helpful tips when you put a random triangle on the coordinate plane. So here, do you guys see how we have a random triangle?
That is a random triangle.
It is a random triangle. So your first tip is to either have a vertex or the center at the origin. What's the origin? 0, 0, right? Okay. Place at least one side along an axis. So either horizontal or vertical. Keep the triangle within the first quadrant. What does that mean?
One quadrant. The quadrant that's first.
Yeah, top right. Because what's so nice about that quadrant?
Everything's positive.
Everything's positive. Good deal. Okay, and the last thing here says use coordinates that make computation as simple as possible. We'll get to that. Okay? On the board, I put some helpful formulas that we've already used before. Mostly just distance formulas, what we'll use today. Okay? Midpoint. How do you find the midpoint? Midpoint is what?
The middle point.
The middle of a segment. Yes. Maybe. Okay, so let's practice labeling our vertices. So do you guys have this random triangle on your paper?
Yeah.
Okay, let's go around and label the vertices. What would this point here be?
0, 0.
Right, we actually know that point is 0, 0. Okay. Now let's shift over to this point here.
0, 0, something.
Okay, well let's first think. I'm moving over how far, do we know?
No.
So let's just call it A. I'm moving over A.
A, 0.
And then, right, am I going up any?
No.
So it's 0. And it's your choice. You can pick any letter. You don't have to use A, I'm just using little a. And then for C up here,
B, C.
Q.
how far over am I going?
I don't know.
We don't know.
B, C.
Q, Z.
Q, that's fine. So I'm going over Q and up how far?
Q, T.
You're going up to Z.
Let's use like height, like H. I'm going up to H or something.
Oh, that's boring.
Okay, T.
That's gonna reach right
Oh,
T.
all
Z,
right.
Q, T.
Oh, QT, that's good.
See what I did there?
That's good. All right, so that's a random triangle. But let's say that they want you to give the coordinates for an isosceles. We know things about an isosceles triangle, don't we?
We do.
They're all
Yeah.
equal.
Well, what's equal?
No,
Two
two
legs.
things.
Your legs are equal, right?
Two base angles.
Yes, good job.
Boom.
So let's start with the easy one. We're gonna move this up a little bit. What is the coordinates of this point here?
Center, center.
0, 0. Okay. Let's do this guy here. Let's do B.
Z, 0.
Okay, now this is the part where it says pick coordinates that will make computations easy. So if I said this was, let's say, just A, then the coordinates of this x coordinate would have to be what then? Half of A. But do I want to work with fractions?
No.
So instead of just calling this a single A, what could I call it?
2A.
2A. Because then what would the x coordinate of this vertex angle be? A. Perfect. Now let's finish this out. What's my y coordinate? 0. And then what do you guys want to call your y coordinate here?
Y.
B. Doesn't
No.
matter.
No.
That's
Oh,
so
you didn't put your
lame.
own letter. Whatever you want to do.
I'm putting Y.
Terrible.
At least
Okay.
No
Z.
fun letters in the alphabet.
There's none.
That's why we
Absolutely.
should
Do,
study
like,
English.
U umlaut.
You.
U with a umlaut.
You tell me how it's written. It's how we need to do it.
U with 2 dots.
Oh, yes, yes. Okay, was that weird or is that okay? It's a little weird. Okay, how do we prove segments are congruent? If I wanted you to tell me, how do you know for sure, what would you do?
You
Measure
say
it if you could, but what if I can't measure it? What if I show you algebraically?
Use common sense.
You
Common sense. What else could you do?
sound confident in
Well,
your
Look at the
answer.
board. What formula would you use?
Act like you know what you're talking
Distance.
about.
Distance formula. I'd probably write that down right
Mine
here.
does work.
The actual formula. You guys write it down. It's on the board.
Okay.
Okay, how do we prove parallel and perpendicular? What needs to be true of something? Slope.
Boom.
If I have something that's parallel, what do we know about slope?
They're equal.
Same slope.
Yes.
And perpendicular, what needs to be true?
Opposite slope.
Opposite, reciprocal. And the slope formula is right over there. Okay, now we're going to try do these two on our own. We're going to try two proofs in the coordinate plane. Okay?
What's the other
Midpoint. Yep.
And what's the
M is slope.
slope?
Yep. M is slope. So it says, prove the medians drawn to the congruent sides of an isosceles triangle are congruent. Well, first we have to remember, what's a median? Do you know?
The middle.
Middle.
Yes, close.
The middle number.
A segment, write this down.
What?
That connects,
We're way off.
you're close.
That's a different.
A vertex to the midpoint of opposite side. So a median goes from a vertex, so a corner of a triangle, to a midpoint of its opposite side.
I just say it. When I say it's difficult, no, I'm just
I can't.
stating an observation.
I don't know why it's your turn.
Okay.
Okay, so we have an isosceles triangle, right? So step one, draw a little sketch. We're going to draw a little sketch on the coordinate plane and label our vertices, okay? So, draw my triangle here.
Online drawing.
We'll just try. Just try.
Okay, somehow.
You just said
Okay, now before we even label our vertices, let's draw in what we're trying to prove. So we're trying to prove the medians that connect the congruent sides are congruent. So if I go from this vertex, I need to go to the midpoint of this side, right? So let's draw on the midpoint.
Wait, we don't know the midpoint.
We'll find it.
We have to guess.
Shut up.
So your goal is to show these two blue segments are congruent.
Ours aren't blue though.
Do you want a colored pencil?
Oh my
Does that make you
God.
feel better?
it's just so childish.
Okay.
I wouldn't be talking to Chris and you're on your phone.
That was very inappropriate.
Okay, now we're gonna move on. Let's go around and label. What's this point? We'll call this one A.
0, 0.
0, 0. Okay, now you gotta think, you guys. Like, think to make your life easy. If this is the midpoint of this side here,
Okay.
what would you want to call it?
M.
We're supposed to say A, B, C, but I'm talking about the coordinates though.
Oh,
Let's just call it
2.
A over A up what? B? We don't know. Just going with it.
Fab.
Okay. Now C, think about it. This needs to be the midpoint of these 2 points. So what does your x coordinate have to be? 2A. Good job. And your y coordinate have to be 2B. It has to be doubled that. Are you so lost?
No, I'm good.
Okay. We're going to skip D for now and let's go down here to E. To this point here. What does your x coordinate have to be?
No.
Think, if the middle's 2A, what would this have to be?
3A.
Not 3. 4A. 4A. And what is your y coordinate?
0.
Okay, good job. Now what would be the midpoint for D? 3A and B. Good job. That's the hardest part. So now from here, it's not difficult. Because now if I want to show they're congruent, what formula am I using? Distance.
That one.
So here we go. Let's first find the distance to A to D. A to D. Here, let's make D our x2, y2. So what's my x coordinate here? My x2 coordinate for D. 3A minus 0 squared plus what's my y coordinate?
B.
Minus squared. Okay. What's 3A minus 0? 3A, but leave that in parentheses squared. Plus B minus 0 is just simply B squared. Okay. How are we doing? What do I have to do to this exponent here, guys? Distribute it to both of those. So what's 3 squared?
9.
And what's A squared? So this is as far as we can go. That's it.
Oh,
Okay. How do we feel? It's kind of weird.
This makes 0 sense.
Why would they make a triangle?
Okay, but just think of this as like manufacturing, guys. Like,
Makes
think,
sense to me.
every pen and pencil you have is the exact same, right? They don't individually make a mold just for my single pencil and a different mold for this pencil here. So how they do that is they write a generic proof, and then it makes every single pencil the same. That's what we're doing right now. We're just making like the mold.
So it makes every single triangle the same.
Right. Okay, now we gotta find the distance to BE. So same thing here. Okay, what is my x2 coordinate, guys? What's E? 4A minus what?
Right.
A squared plus 0 minus B. Okay. What's 4A minus A? 3A, leave it in parentheses, squared. 0 minus B is negative B, but what's negative B squared?
No way.
It's still
the
just B
same.
squared. Well, we should get the same. Okay, distribute the 2, so I'm going to get 9a squared plus b squared.
Yo.
Is that what we wanted?
Yeah.
Yes.
So look, you just proved they're the same.
Got him.
We just spent 3 hours.
Oh, we got a lot.
Equal.
But it's cool.
We have to do another proving thing.
Why don't we do another one, or do you want to start your homework?
Start homework.
Homework.
I definitely know this.
Okay, that's fine.
Ask on the first.
You have a book assignment, I'll put it on the board.
What?